Hello, I'm Marcus. Welcome to Lab 1. So in Lab 1, we are supposed to find an object with constant velocity. That means that the change in velocity is going to be constant and have zero net force. To show this, I used a basketball rolling on a flat surface, as we can see here. Although it may be upside down looking to you, this isn't really going to matter because right here is the axis and this is a positive x. Even if I flipped it around and made this the negative x, all it's going to do is flip our graph to the negative direction as time goes on. Really, flipping our graph negative positive means left or right and is really just orientation preference. It isn't going to matter much as long as we represent this in our model. Since for this lab we are going to assume that there's zero net force acting on our object, in the code right here on Newton's second law, we are setting F net equal to 0. So that means no matter what the ball's mass is or the change in time, this half of the equation will always equal 0. And this is significant because that means that our final ball velocity is always going to equal our initial ball velocity, so there's no change in velocity. This means that when we go to the position line, that means that the velocity is constant, so the slope of the line is going to be straight. So we can predict that for the graph of this, we're going to have a straight positive line showing the movement. And right here, if we run our module, we'll see that this is true. As the ball moves, it is moving in the positive direction at a constant velocity, giving it a straight line. Finally, on Google Docs, I have compared the model and the experiment data that we received. The blue dotted line is going to show our experimental position over the course of time, and the red is going to show our model. As you can see, in the very beginning they stay very close to each other, but as time goes on, the blue one, the experiment, is going to start to decrease and drop below the model prediction. This is because although in our model we are assuming that there's going to be zero net force on our object, in real life and in the experiment we cannot guarantee this. This is because things such as friction acting on the object as it rolls across the concrete and the air drag the ball is encountering as it moves. So over time in our experiment there is force acting on our object and slowing it down. But since we made the assumption that there was zero net force in our model, we're always going to have a straight line since we have constant velocity. So in our experiment, it's not going to be possible to figure out all the pushes and pulls and add it up to figure out what gave it a zero net force, because in reality it didn't have a zero net force in our experiment. And this also explains the drop as we move in time from our experiment and our model data. So really the most important thing we learned here from Newton's second law is that without any net force acting on the object, our velocity is going to remain constant. So whatever object is in motion is going to stay in motion with a constant velocity until some sort of outside force acts on the object.